Good evening. Now again we will see one problem that is related with our flanged beams. Now in this we have already seen the two problems, and today we will go with third problem on flanged beams. So we have this as third problem. So find the moment of resistance of flange section. Now here I have kept this as 550 only. The changes you can see, and this is 8 above 20 mm torque. Now we are going to solve this to calculate the moment of resistance. So now given data we have and we know how we will go. So already we have seen we have first we have to say neutral axis in flange. This we have to keep in mind and we have to follow the same. Second we have df which is less than 3/7 of xu, and if these two not satisfied then only we can go with df greater than 3/7 of xu. Already I mentioned in this our rectangular block is greater than the flange. Here rectangular block is small than flange. Now you can see this. Assume neutral axis in flange. So we have same xu 0.87 Fy AST. Now we have 8 bars. So 2513.27, 0.3620 into 1000. Now we have 126.03 millimeter greater than 100. So our assumption is wrong. Neutral axis lies in web. Now we have to see df less than or equal to 3/7 xu. Now formula we know, we have substituted value in this, and substituting value in this xu, we are going to get 129.12 millimeter. Now we have to go that 3/7 of xu because we have to now check it for second step. We are second criteria, and now we are with 3/7 xu, which is 3/7 129.12 55.33 less than 100 mm. Then our assumption is wrong. Neutral axis lies in web, but we have df less than 3/7 xu, and then we have to use here yf is equal to 0.15 xu plus 0.65 df, and in this equivalent depth my stress is 0.45 FCK. So now you can see, but df we have, so just I have mentioned over there, that is df that is greater than 3/7 xu, and now we will go with that step. So you can see here we have minus 0.45 FCK BF minus BW, and this is 0.6 df. So already I mentioned, we have seen that we are going to separate out 0.15 xu and 0.65 df. Xu we have taken common, and from this we are going to get this value of xu that is equal to 166.63 millimeters. Now we have to check 3/7 xu max. Also we have to check 240, which is greater than 166.63 millimeters. Section is under reinforced. Now we have to calculate yf, and calculating value of yf, we are going to get 0.15 into 166.63 plus 0.65 into 190. So this is equivalent depth, and in this equivalent depth our stress in concrete is 0.45 FCK. So equivalent depth we have this, otherwise we have that stress is some portion we have parabola, and it is difficult to calculate by exact value. And now then we will go with 0.36 FCK XU BW D minus 0.42 XU. This will be as it is, as we have in second case, that is DF which is less than 3/7 XU, and plus we have this will be, here we have YF equivalent depth, and this is YF by 2. Now we will substitute the values in this equation, which will give us moment of resistance 0.3620 166.63 into 250. Now this is 500 minus 0.42 166.63, and then second portion we have plus 0.45 FCK into 1000 minus 250, that is BF minus BW, and then we have this will be into 90, which is equivalent depth. 500 minus 90 by 2, and that will gives us value that is of moment, and that moment is 405.39 kilonewton meter. So now likewise we have to go. So this IXU plays very important role in case of your flange beam, and which will divide your problems into three types. So these three types are most important. I will mention first neutral axis in flange. This will be same as your singly reinforced section. Second, we have DF which is less than 3/7 XU. So my whole flange, that is with 0.45 FCK, and then DF which is greater than 3/7 XU. I have to find value of YF, and in on this equivalent depth my stress is 0.45 FCK. So these three we have problems which are related with your flange section. So today we will stop here only. Thank you.